Hello and welcome to the homework solutions video for calculus section 1.2. So we're on page 53 in your book. Number 3, so we want to solve this, find out what is the limit based on a table. Because here if we plug in the number 2, we're going to get 0 over 0. All right, so we're going to try to solve it through a table. There's much easier ways to solve this, but that's where we're at right now in the course. So we're going to plug in values of x as they approach 2. So as they approach 2 from the left and as they approach 2 from the right. So I'll do the first one. We would have 1.9, right? We're going to plug in 1.9 minus 2 over 1.9 squared minus 1.9 minus 2. And when you put that in your calculator, you'll get 0.3448. All right, so that's what we're going to put here. So I know that you can plug things in and put in your calculator, so we'll put 1.99 and then 1.999 in. And here are your answers as you do that. 0.3344, 0.3334, you plug in 2.001, you get 0.3332, 0.3322, and then 0.3226. So the limit is, what is the y value that this function is approaching as x is approaching 2? So if we just look at this, it's somewhere between 0.3334 and 0.3332. So I would say that's 0.333 repeating is what the limit is. Okay. So that's kind of an estimate of the limit using a table. All right, now we're going to do a few graphs from the book. So on page 54, we've got this graph. All right, so the limit is where your hands come together. So what is the limit as the x value approaches 3? So we're here at 3. As x approaches 3, the y value approaches 1. Okay, so there's no break in that function. Your hands can come together at 1, so the answer is 1. All right, number 13. Let's look at that graph. So as x approaches 2, we have a piecewise function here, but we're just going to trace from the right as x approaches 2 from the left as we get close to x equals 2. All right, where do our hands come together? The y value where our hands come together is 2. The algebra solution is 0 because this is a piecewise function when x is equal to y is equal to 0. That's not the calculus solution. The calculus solution, the limit is 2. The y value that is being approached is 2. All right, 15. So as we come from the left, as x approaches 5, here we are, we're getting to 5. The y value is -1. From the right, when we get to 5, the y value is 1. So our hands do not come together, do they? They don't touch. Our fingers don't touch. So this limit does not exist. Now there's a way to get an answer from the left and from the right, but that's for a future section. Right now you just have to say it doesn't exist. Then number 17, coming from the left as x approaches pi over 2, the y value is positive infinity, right? It just keeps going up and up and up and up and up as we come from the left. At when x is pi over 2, the y value is infinitely large. When we come from the left, the limit is negative infinity, okay? The y value is infinitely small. So our hands never come together. They go apart forever. So that's another one, does not exist. Okay, great. Next one is number 21. So this is an epsilon delta problem. 21 says find the limit L and then the delta greater than 0 such that f of x minus L, the absolute value of that, is less than 0.01. So 0.01 is your epsilon. We want to find delta. Okay, so number 21, the limit as x approaches 2 of 3x plus 2. Well, the limit we're going to plug in and we get a number that's going to be 3 times 2 plus 2. So the limit's 8. Okay, so we have the form, the absolute value of f of x. I'm going to go ahead and write it out. F of x minus L less than epsilon. So f of x is 3x plus 2. The limit L is 8. So minus 8. And the problem says less than 0.01. That's our epsilon. Okay, that's going to be 3x minus 6, absolute value of that, less than 0.01. Well, I need the form to find delta, the absolute value of x minus c less than delta. Okay, well, I don't have x minus c here, so, but to get x, I could divide both sides by 3. And I would have the absolute value of x minus 2, right? 6 over 3 is 2. Less than 0.01 over 3 is 0.0033 repeating. We'll just round it to that. So now c is 2. 2 is c. So now I have this x minus c less than delta. And that delta value is 0.0033. Okay? That's how you do it. Pretty easy. Okay, now we have a few true-false questions, and 42 is just a... So 42A says, answer each of the following and give reasons for your answer. If f of 2 is equal to 4, can you conclude anything about the limit of f of x as x approaches 2? Well, let's draw something out here, and this can relate to both problems. F of 2 is equal to 4. That means x is 2, and the y value is 4. So I've got a point here. Can I conclude anything about the limit from that information? Well, the answer is no. What if I have a function like this that goes like this, but it's a piecewise function, and we have that? So the limit in this particular case would be whatever y is right there. That L, the limit is that. It's not necessarily that point. So the answer is no. I really don't have enough information. Now part B says, if the limit of f of x as x approaches 2 is 4, can you conclude, anything about f of 2? Okay, this time it says the limit is 4. Can I conclude anything about... So this is basically the opposite version let's say we have a function, but it has a hole right there, and the limit is 4. But the algebra solution is, let's say, 1. Okay, so we can't conclude anything about f of 2. We can only state that the limit is 4. Okay, so really there's not enough information. We can't conclude anything on there. So the answer is no. All right, let's see if I can put 43 on here. So 43 is true or false. If f is undefined at x equals c, then the limit of f of x as x approaches c does not exist. Well, that's going to be false. Or it's not necessarily true. Let's draw this out. So it says undefined at x equals c. So let's say this is c. Well, let's say we have a function that has a hole right there. Okay. In this particular case, does the limit exist at c? Yes, it does. It's undefined at c. We can't get an algebra answer, but our limit is L. It just has a hole right there. So we can't necessarily say that the limit doesn't exist. It might not exist, but this is a case where it does exist. So that answer is false. All right, let's see if we can use this same drawing for number 45. Maybe not. So 45, if f of c is equal to L, then the limit must also equal to L. Well, that's not necessarily true. I'm going to go ahead and draw a new graph for 45. It says f of c is equal to L. All right. So this would be c. This would be L. F of c is equal to L. So that means does that mean the limit has to be L? No. We could have a piecewise function like this, where the limit is equal to some other number, let's say z. All right, so the limit, your hands come together when y is equal to z, but the algebra solution is L. So the answer is false. The two don't have to be equal. They can be, but they don't have to be. Okay, if we got rid of that and put that right there, then it would be true. Or not z. They would both, the limit would be z and the algebra solution would also be z. But it doesn't have to be. Could be like this. All right, and then 46 says that if the limit as x approaches c is L, then f of c is equal to L. Well, that's just basically saying the opposite of 45. If the limit is L, okay, I'll draw you a new graph here. Okay, so we're saying, let's draw a function here. This is c, and it says the limit is L. Okay, that's true. That's where our hands come together at c, the y value is L. But does f of c have to be L? No. F of c could be something else, just like in number 42. It could be H for Hannah. Okay? So the limit, the algebra solution could be H, but the limit is L. Okay? Because it's this kind of situation where you're undefined at C. All right, so the answer to 46 is false. So a bunch of falses. No, no, and false, false, false. All right, that does it for the solutions for your first homework assignment, and I will talk to you next video.